All right, so what about tables? How do you identify linear versus nonlinear functions in table form? Well, again, it goes back to what we were just talking about. With linear, the slope is consistent. And so what we can do, wrong way. What we can do is we can look at these tables and can look at the rise and run numbers. Okay, so for example, this was something we did in the last tutorial. If I look at the jumps here, from 3 to 6, it's plus 3 again, plus 3 again. And for the rise numbers, here this looks like subtract 8, subtract 8 again, and here subtract 8. And so no matter which one of these I take, the slope, rise over run, is negative 8 thirds. Also here, negative 8 thirds. And also here, negative 8 thirds. So the slope, no matter where I look on this table, the slope is consistent, which means that when it's graphed, it must make a straight line. Okay, whereas this one, if I take a look at rise and run, let's take a look at the run numbers on top. Got a plus 2. Now these are consistent, okay, but that's never enough. We have to look at both sides. So let's look at the rise numbers now. 2 to 11 is 9. 11 to 33, that's plus 22. And 33 to 88 is plus 55. So if I were to change these to slope, rise over run, rise is 9, run is 2. This one, the rise is 22 over 2, and the last one is 55 over 2. All right, so as I travel through this table, the slope changes. The slope is not consistent, so this must be some kind of nonlinear function. So this one, when slope is consistent and it's the same throughout, linear. For nonlinear functions, the slope changes as I jump from part to part on the table. Okay, just like on our graph back here, as we jump from place to place on the graph, the slope changed. All right, so that's how you identify linear versus nonlinear when it comes to tables.